So it's important to know when we're adding and subtracting fractions that when we're adding the parts, the size matters. And I'm going to write that down. That's important. The size of the fractions matters. How do I know what a fraction is? Well, a lot of us were taught of fractions as numerator over denominator. Which bothers me because that really has no meaning. All the numerator means is what is the top number, and all the denominator means is what is the bottom number. So, but luckily for me, I was taught with something a little more. And for most fractions, what I can do is I can think of them as part over whole. And that sucks, so we'll try to make that look a little nicer. Part over whole. Basically, this is the number of parts we have, and this is the number of parts that make up a whole or entire, whatever object we're dealing with, okay? So if I have 1 out of 7, literally that says I have 1 part, 7 parts make a whole. Plus 5 parts, 7 parts make a whole. These have the same denominator. What does that mean? That they have the same denominator. I can do better than that, come on. Denominator is that they have the same size pieces, which is a big deal, because then I can add the parts. I have 1 part out of 7 plus 5 parts out of 7 gives me 6 parts. Out of what? The size of the parts don't change just because we add them. The denominator, the size, stays the same. So the denominator stays the same. So that's easy to do when they're the same denominator. We basically have the same size pieces. We can add the parts and it stays the same. I can do the same thing with 2/3 plus 2/3. I can add the parts on the top. 2 parts plus 2 parts gives me 4 parts. Out of, what was the size of the pieces? 3. The difference on this is I wouldn't leave it as 4/3, and you're like, yeah, no, make it a decimal. Okay, first of all, we are going to be using some technology in this, and that doesn't bother me at all. But if I take 1/7 plus 5/7, and I do 1/7 plus 5/7, and I want to put that as a decimal, no way. That is not an exact decimal. It's a mess. We don't want to mess with that. That's not the purpose of this. Okay? Now, you might have a calculator that handles fractions. And so, like for mine, I can go to the, number, and turn it back into a fraction, and it will totally write that as a fraction for me. And I can do the same thing with 2/3 plus 2/3. I do not want that as a decimal. So what we would do is we either get a calculator or we, learn all the decimal rules. Either is fine, but I'm going to go ahead and say, let's change that number to a fraction, and it'll give me 4/3. But I still don't want 4/3. What I would want is, yes, I mean in mathematics, improper fractions are fine. So fraction form is fine. Okay. But a lot of time we do want these as mixed numbers because they have more meaning at the end. So what I do is I do that 4 divided by 3. 3 goes into 4 one time. 1 part left over. That 1 is still being divided by 3. So what we do is we take that remainder and we put it over the 3. That 1 is still being divided by the 3. And so this is the same thing as 1 and 1/3. Or sometimes 1.3 going on forever, but these are the two that I really want you to be able to handle. What is 3 3/4 plus 2 3/4? Well, when they're mixed numbers, I could just go 3 plus 2 is 5, 3 plus 3 is 6, but I don't want 5 and 6/4. That's not helpful to me. So what we do in mathematics is we say, you know what, we really need to learn how to turn these mixed numbers into fractions, because really math with mixed numbers is not very useful. So we do kind of the opposite of what we did. Instead of dividing it out, we go, look, I have 3 whole parts. I have 3 whole whatever this is, right? And I know that 4 parts make up a whole. So if I've got 3 whole and each of them is worth 4 parts, 3 times 4, they're worth 12 parts. Plus the other 3 gives me a total of 15 fourths. Just to visualize what we did, I took 1, 2, 3, and what is that? 3 out of 4. And I said, I'm going to take these big 3 whole things and I'm going to cut them into fourths so that I can just get parts here. Well, those 3 times 4 are 4, 8, 12 parts, plus the other 3, 15 parts over 4. I can do the same thing with the 2 and 3 fourths, 2 times 4, plus 3. Those 2 wholes are worth times 4, 8 parts, plus 3, 11 parts out of 4. And now I can add these, 15 and 11, 26 over 4. And we also have to catch that we have to simplify these. See, 26 and 4 are both even, which means I can divide both the top by 2 and the bottom by 2. And why can we do that? Well, what is 2 over 2? 2 divided by 2 is 1. I'm basically dividing this by a very complicated looking 1, which means I'm not changing it. I'm just writing it in a reduced or simplified form. 26 divided by 2 is 13. 4 divided by 2 is 2. I am fine with this answer. 13 divided by 2 goes in 6 times with 1 remainder. So that would be 6 and 1/2. This one has a decimal. It would be 6.5. That one's actually fine. But I don't want to have decimals that are rounding off and complicated decimals. So don't just turn all these into decimals. You need to make sure you know how to handle them as fractions. What do I do when the denominators aren't the same? Well, I cannot add these pieces. This is basically saying I've got 1 out of 5, which, let's see, what does 5 look like again? 2, 3. My pieces suck. I can do better than that. That looks good. 1 out of 5 and 1 out of 4. That is not 2 parts. You can't just add them. They're not the same size. I can't add quarters and pennies and say I've got 2 of something. It doesn't work that way. We treat them all as pennies and then we say, well, that's 26 cents. Same thing here. These need to be the same size. How do we do that? Well, the denominator is the size, so we make the denominators the same. Basically, I take 5 and 4 and I can count by them. 4, 8, 12, 16, 20, 24, so on and so forth. I count by the 5s, and I find a multiple that they have in common. Well, these can both become 20. That's 5 times 4. It's 4 times 5. This is wrong, though. 1/5 is not the same thing as 1 over 20. So what happens when we make this denominator 20 is we have to multiply the top by 4 because we end up with more parts when I cut it into smaller pieces. Same thing with this, top and bottom by 5. So 1 out of 5 is what? The same thing as 4 out of 20. Plus 1 out of 4 is the same thing as 5 out of 20. And now that they have the same denominator, the same size, these can add to give us 9 out of 20. Okay? And yes, I'm okay with your technology can do this. 1/5 plus 1/4. But I do not want this answer. You need to make sure that you have some technology that can turn that back into a fraction, and I'm fine with that. Okay? What about subtracting? 1 and 1/4 minus 3/4? Well, these have the same size, but I cannot do 1/4 minus 3/4. So once again, we want to turn this into an improper fraction. Multiply and add. 4 plus 1, let's say 5/4, minus 3/4. Now I can subtract the parts. 5 out of 4 minus 3 out of 4 would leave me with 2 out of 4. 2 over 4, they're simple, can be simplified since they're even by 2. 2 divided by 2 is 1. 4 divided by 1 is 2. So we're just left with 1/2. 2 3/8 minus 1 3/4. I do not want the mixed numbers. Multiply and add. Multiply and add. 16 plus 3, about 19/8. Minus 4 plus 3, 7/4. This is not 12/4. We never subtract the denominators. The denominators are just the size of the pieces. What we do is we have to make them the same by taking the second one. Now I have a lot of people that would multiply this one by 8 and this one by 4, which is not wrong, but it's a lot harder than it needs to be. And so if you can see that they both become an 8, awesome. If not, I recommend listing some multiples for a 12, 16, 8, 16, 24. And people are like, oh, look, they can both become a 16. I would argue the least common, they could just both become an 8, which means I don't even have to mess with the 19/8. I just need to take that second fraction and multiply it by 2, top and bottom, and now they're both 8s. So now I have 19/8 minus 14/8 gives us 5/8. Keep in mind, if you are using technology with this, I don't recommend leaving it as a mixed number in the question. So you would still need to be able to do this first step and this first step. If I'm using technology, I can do 5/4 minus 3/4. 5/4 minus 3/4, and it should tell me 1/2. Just like I could do, 19/8 minus 7/8. 7/4, let me make sure I did that right. Yeah. And it will have no problem doing that, okay? But you need to make sure that your technology can handle it. Putting these in as mixed numbers would not be useful. So make them improper fractions first, and then handle them. Multiplying is a whole different game. I'm going to start with some simple ones that should make sense, and then we will kind of generalize with a rule. See, this basically says, what is 1/2 of 1/2? If I take half of a half, if I take a half, and I cut that in half, I now have 1/4. How do we get that? Well, 1 times 1 is 1. 2 times 2 is 4. Notice the denominator changed this time, because when we multiply, we end up actually multiplying the denominator, so we get different size pieces at the end. If I take half of something, yeah, the pieces are going to change size. But basically what we do is we multiply straight across. One half times 2/3. I can do, well, visually, half of 2/3. If I've got 2 out of 3, and I keep only half of that, I now have 1/3. But I can do this algebraically, and we need to know how to handle this algebraically. It should make sense, but I should be able to multiply these straight across. 1 times 2 is 2. 2 times 3 is 6. Our answer is 2 6. Somebody's like, you said it was 1/3. You're a liar. No, I'm not. 2 and 6 are both divisible by. So don't forget to simplify to get that 1/3 at the end. Okay? So this should make sense, and the rules apply when it's easy, so that when things get more complicated, we can still get the same answer. See, what is 2 1/2 times 3 1/5? I don't know off the top of my head. It's messy. But what can I do? Well, like we did before, I don't want to deal with these as mixed numbers. So I'm going to multiply and add. 15 plus 1 is 16/5 times 2 times 2 plus 1. How about 5/2? Now I can multiply these straight across. 16 times 5 is 50 plus 30, or 80. 5 times 2 is 10. 80 divided by 10 is 8. Okay, so this one's harder to visualize, but the rules don't change just because the numbers get more complicated. 2 5/8 times 1 1/3. Once again, let's turn these into improper fractions. 16 plus 5 would be 21 over 8 times 3 plus 1, how about 4/3? Now, people get weirded out. They're like, oh, I got to make these denominators the same. No, you don't. Not when I multiply. I can take half of a third or a fourth or a fifth. I can cut anything in a half. The denominators don't have to be the same to multiply them. Okay? What do we do? All we do is just multiply straight across. 4 times 21 is 84. 8 times 3 is 24. Both of these are even, so we would reduce them by 2. How about 42 over 12? Still both even, so we reduce them by 2. 21 over 6, not even, but 21 and 6 are still both divisible by 3. So how about 7 over 2, which I'm fine with, or 2 goes into 7 3 times, with 1 part left over, 3.5. Okay? You will need to be able to leave these as fractions. How do we divide? Short answer is we don't. You can technically try to divide straight across and it will work, but I don't recommend it because it's not going to work here very soon. But logically, if I have 4/3 and I'm dividing it by 1/3, I'm basically saying, how many 1/3 do we have? Let's pull out 1/3 from 4/3. Shoot, I've got 4. I've got 4/3. That's 4 1/3. You don't like that? That's fine. So how do we get that 4 if you don't like it logically? We don't divide by the fractions. We don't divide straight across, even though you can. It won't work. It works so not often enough that we just don't do it. What do? We multiply by the reciprocal. And the reciprocal is where we take the second one, whatever we're dividing by, and we multiply by b over a. It flips. So instead of doing 4/3 divided by 1/3, I'm going to do 4/3. Change it from divide to multiply. 3 over 1. Why does that make our lives any easier? Well, because multiplying fractions is really easy. If I multiply that straight across, 4 times 3 is 12, 3 times 1 is 3, and 12 divided by 3 is 4. I thought the answer would be 4 logically. But the idea is that I want a process that's going to get me the answer when it's easy and when it's harder. What is 4/3 divided by 1/6? I can't divide this straight across. But what can I do? I can change this from 4/3 divided by to 4/3 times the reciprocal. Now multiplying these straight across, 4 times 6 is 24. 24 divided by 3. Awesome. Okay? Why does this work? I'm going to show you real quick. You're not going to necessarily like it, but I think it's important to stop and take a second to figure out why. See, I'm going to rewrite this division. I'm going to rewrite that as a big fraction. 4/3 divided by 1/6. And some of you are like, why? Why would you ever do this, right? Well, I'm going to show you because we don't like this. We don't like a fraction over a fraction, but that division is still here in that line. And if you didn't want this, remember, I can multiply anything on the top and the bottom, and I can clear out this fraction, basically. So what I'm going to do is I'm going to go to the bottom and go, that's terrifying to have a fraction in the denominator. So I'm going to multiply that by the reciprocal, which is what? And if I do it to the bottom, to keep it equal, I do it to the top. What happens on the bottom is I just end up with 6 over 6. I end up with just 1 down there. So it's basically eliminated. And on the top, I end up with just 4/3 times 6 over 1, which was our 24 over 3, or which was just 8. So it's basically a way of clearing out the division by multiplying. Multiplying by the reciprocal clears out the division, and it simplifies the question. But this is the why. If you don't like that, that's fine. You don't have to do it, but that's why. It is because we multiplied by the reciprocal to clear out that scary denominator. What if I had 2 1/3 divided by 5/8? I don't like this as a mixed number, so let's 2 times 3 is 6 plus 1. I'm not going to change anything. I'm just rewriting the question at this point, okay? Now I'm going to, as a separate step, change it from dividing to multiply, and the second one by the reciprocal. Multiplying these straight across, 7 times 8 would be 56 over 15, which I'm fine with. 56 is divisible by 15. There it is. 56 divided by 15. It goes in 3 times. So I go 3 times 15. Oops. It goes in 3 times with a bunch of leftover. 3 times 15 was 45. That leaves us with 11. That's our fraction. So it's 3 and 11 over 15. Either of those answers I'm fine with. There are times where we're going to want mixed numbers. There are going to be times where we want improper fractions. Okay? What if I had a mixed number and a mixed number? Change them both. 48 plus 5, how about 53 over 6? Divided by, times and add, 6 plus 1. I have not changed anything. Nothing needs to flip at this point. What we're going to do now, first of all, is create some more space. Sorry about that. Okie doke. Let's see. Nope, not going to do it. Let me shrink this way a little bit. All right. So we do 53 over 6 times the reciprocal. 53 times 2, 106. 6 times 7, 42. Both of those are even, which means they're both divisible by. 53 over 21. I think that's done. I think 53 might be prime. So we'll do that. 53 divided by 21. 21 times 2 would be 42. That looks like it's about big enough. 3 would have been too big. And that leaves us with 11. So 2n, 11 over 21. So one of the other things we're going to do, and once again, I'm going to use technology where I can. I'm not trying to beat you up with this math, but we are going to do order of operations still. So think about PEMDAS. For operations, and we start with the parentheses. Well, this is all going on inside the parentheses. I need to do that first. 1/3 plus 1/2. I'm not killing myself over this. 1/3 plus 1/2. I am not leaving it as that decimal. You need to be able to have that as a fraction. So how about 5 over 6? Now I go down and I say, oh, we're done with what's in the parentheses. I see some exponents. What about that? What is 5/6 squared? Well, 5/6. I have a little squared button. I can do that. Or if you prefer, you could do 5/6 times 5/6. I don't think that may not work. Oh, it did work. So just be careful. It gets a little weird with the formatting sometimes. But we got 25 over 36. So now I've got 1/5 times 25 over 36. 1 times 25 is 25. 5 times 36 is 180. Or I could just take my calculator. What was that? Times 1/5. Wait, I thought I had 25 over 180. Well, we did. 25 over 180 simplifies to 5 over 36. So depending on your calculator, you could have one that handles fractions and simplifies. So don't complain about these, just learn to handle them, okay? Next, parentheses, no, exponents, okay? I should color code, we multiply next, okay? So this is 4/3 squared, 4/3 times 4/3, about 16 over 9. Now I'm going to do 1/4 times 16 over 9. Put that in your calculator, hit enter. I'm looking at about 4 over 9. I would now need to give these a common denominator. 3 is a whole number. Well, it can be written as a fraction, 3 over 1. Common denominator of 9 would be 27 over 9 minus 4 over 9. Would be 23 over 9. Somebody's like, I would not have done it that way. Okay, if you want to do 3 minus 4/9, 3 minus 4 over 9. I'm okay with that, as long as you make sure that you can turn that back into, first of all, I have to push the right buttons. Oh my goodness. Sorry about that. Turn that back into a fraction. Okay? But you also need to know 23 over 9. 9 goes into 23 twice, leaving us with 5. So 2 and 5/9. And some of you have buttons that it'll turn it into that mixed number as well. So don't get too upset about this. There are options here, okay? Parentheses, exponents, multiply, divide. All we have here is adding and subtracting. So 3/4 minus 1/2 plus, let's make this a fraction. 8 plus 1, 9/2. Do not make that 10/2. We do not add before we subtract. We don't always subtract before we add. We do it from left to right. Which means I'm going to take these two and give them a common denominator. 3/4 minus 2/4. 3/4 minus 2/4 would be 1/4. 1/4 plus 9/2. Now I can add these, but they still need a common denominator. 1/4 plus 18/4. How about 19/4? 4 goes into 19 4 times. That's 16, leaves us with 3 out of 4 left. Feel free. Now you do need to, this right here on the top, I'm not putting this in my calculator. But if I got this second line, I can turn things all into improper fractions. Then I can do 3/4 minus, what was it, half? Plus 9/2. That's not the answer I want. Make sure that you have that as a fraction. Okay? I'm curious, let me look real quick. Does it have an option for decimal factor? Or maybe, let me try that. Nope, doesn't work. Alright. So I don't know if mine will turn that back into a mixed number. A lot of yours will. You got choices. But that's it. So that's kind of a quick overview on fractions. I'm not expecting you to memorize all these, but you either need to know them or know how to use your resources to get those answers. So work through them. If you're having problems, come in. I can help you with the technology. And the answer may be you need better technology. You might need to go buy another $5 calculator that's going to do better for you. Okay? You don't need this big fancy calculator I'm using. They have these little $5 ones that work perfectly fine. So get going on it, and we got a lot to keep going on. So don't spend too long on these fractions. Let's get past them.